Dear friends, welcome to Bond with RK Chemistry YouTube channel. In this video, I will explain the most important 30 identification tests of organic functional groups. These are very important. These are frequently appeared in various competitive examinations such as IIT-JEE, NEET, JEE, and other PG entrance examinations. Completely watch the video. Don't skip the video.
Or ignition test. This test is used to distinguish aliphatic compounds and aromatic compounds. In case of aliphatic compounds, there is a formation of a non-sooty yellow flame. In aromatic compounds, there is a formation of a sooty flame. We know that alkyl or aryl halides, these are not flammable. So in this case, there is no formation of flame, not flammable. Bromine water test. This test is used for the identification of unsaturated bonds in the given organic molecule. The reagent is bromine dissolved in water or 2% bromine dissolved in carbon tetrachloride. This one is used to identify alkene, that is C double bond C, alkyne C triple bond C, and also it is used for identification of phenol and aniline. We know that the color of bromine water is reddish orange. In presence of these functional groups, there is a decolorization of a reddish orange solution. In case of phenol and aniline, there is a formation of a white precipitate. Base test. This is also used for identification of unsaturated bonds in the given organic molecule. You can identify alkene, alkyne. The reagent is 1% KMnO4. The color of KMnO4 is pink color. In presence of these functional groups, there is a decolorization of pink color. Tollen's test. The reagent for Tollen's test is ammoniacal silver nitrate. The active complex in Tollen's reagent is AgNH3 twice plus. This one is used to distinguish terminal alkynes with internal alkynes. The terminal alkynes form white precipitate with ammoniacal silver nitrate solution. Ammoniacal cuprous chloride test. This one also used for distinguishing terminal alkynes with internal alkynes. The reagent, the active component of this reagent is CuNH3 twice plus. The terminal alkynes form red precipitate with ammoniacal cuprous chloride. Beilstein test. This is used for identification of alkyl halides. The halogen is chlorine, bromine, or iodine. Alkyl fluorides cannot be identified by using a Beilstein test. Alkyl fluorides cannot be identified. In this test, the copper wire is heated. After that, the copper wire is put in the given alkyl halide compound, and after that it is put it on the flame, Bunsen flame. There is a formation of green flame. This one indicates the given organic compound is alkyl chloride, alkyl bromide, or alkyl iodide. Alcoholic silver nitrate test. This is also used for the identification of alkyl halides. Here halogen is chlorine, bromine, and iodine. The reagent is silver nitrate dissolved in ethanol or ethyl alcohol. In case of alkyl chloride, there is a formation of white precipitate. Alkyl bromide, there is a formation of pale yellow precipitate. Alkyl iodide, they form yellow precipitate. you can easily distinguish alkyl chlorides, alkyl bromides, alkyl iodides by using alcoholic silver nitrate test. Sodium iodide test. The reagent is sodium iodide is dissolved in acetone. This one is used for the identification of primary, secondary, alkyl chlorides, alkyl bromides only. You cannot identify tertiary alkyl chlorides. Tertiary alkyl chlorides cannot be identified, and also alkyl fluorides, alkyl iodides cannot be identified by using sodium iodide test. When alkyl chloride, alkyl bromide, primary and secondary, are treated with sodium iodide in acetone, there is a formation of sodium chloride or sodium bromide. These salts will be precipitated in acetone solution. And the next test is Ceric ammonium nitrate test. Ceric ammonium nitrate test. This test is used for identification of alcohols. When you treat alcohols with NH4 twice CeNO3 6, there is a formation of red color complex. This one indicates the compound contains alcoholic functional groups. Iodoform test, the reagent is sodium hydroxide, potassium iodide in iodine, or you can use potassium iodide and sodium hypochlorite. This test is used for the identification of ethanol, secondary alcohols with methyl at alpha position, acetaldehyde, and methyl ketones. Okay, this one is not used for primary alcohols other than ethyl alcohol cannot be identified, and also tertiary alcohols cannot be identified. Here there is a formation of yellow precipitate. The yellow precipitate is due to formation of iodoform, that is CHI3. Lucas test. The reagent for Lucas test is anhydrous zinc chloride dissolved in concentrated HCl. You can distinguish primary alcohol, secondary alcohol, and tertiary alcohol by using Lucas reagent. In case of primary alcohol, there is no formation of alkyl chloride when you react with zinc chloride, when you react with Lucas reagent. That's why there is no separation of layers. But when you treat with secondary alcohols with Lucas reagent, there is a formation of alkyl chloride within 1 to 5 minutes. So there is a formation of two layers within 1 to 5 minutes in the case of secondary alcohol. Tertiary alcohols, they readily form alkyl chlorides. So in the case of tertiary alcohols, there is a formation of two layers immediately. So there is a immediate separation of two layers. Jones reagent, the reagent Jones test, the reagent is chromium trioxide dissolved in aqueous H2SO4. After that, it is diluted with the water and acetone. This one is used for to identify primary, secondary alcohols and also aldehydes. In this case, there is a disappearance of orange color. The chromium trioxide or chromic acid has orange color. This the orange color will be dissipated and there is a formation of green or blue-green precipitate in Jones test. Victor May's test, this one is used to distinguish primary, secondary and tertiary alcohols. The reagent is first the given alcohol is treated with the potassium plus iodine. After that, this one is treated with silver nitrate. After that, it is treated with nitrous acid and sodium hydroxide. In case of primary alcohol, there is a formation of red precipitate R, And secondary alcohols, they form blue, and tertiary alcohols, there is a formation of colorless RBC. Primary red, secondary blue, and tertiary colorless. Ferric chloride test. The reagent is neutral ferric chloride solution. This is used for identification of phenol and its derivatives. When you treat ferric chloride with phenol or its derivatives, there is a formation of a complex. There is a appearance of blue, green, red, or violet color. Phthalate dye test. This is also used for identification of phenols. The reagent is phthalic anhydride. After that, it is treated with concentrated H2SO4 and sodium hydroxide. Here there is a formation of a pink dye, that is phenolphthalein. Libermann's Nitroso test. This is also used for identification of phenol. The reagent is nitrous acid. When you treat with nitrous acid, there is a formation of red color, and this red color after that changes to blue color when you add sodium hydroxide. Initially there is a formation of red color. After that it will be converted into blue color when you treat with sodium hydroxide. 2,4-DNP test. The reagent is 2,4-dinitrophenylhydrazine. This is used for the identification of carbonyl compounds, identification of both aldehydes and ketones. In this case, there is a formation of yellow, orange, orange-red precipitate. Sodium bisulphite test. This is also used for aldehydes and ketones. The bulky ketones cannot be identified by using sodium bisulphite test. The reagent is sodium bisulphite, sodium hydrogen sulfide, that is NaHSO3. There is a formation of white precipitate with aldehydes or ketones. Schiff's test. The reagent is para-rose aniline hydrochloride. This is a fusion dye treated with sulfur dioxide or sulfurous acid. Actually, this fusion dye has pink color. The color of this dye is pink color. When you treat with sulfur dioxide or sulfurous acid, there is a decolorization of pink. This total solution, this total composition is called as a Schiff's reagent. When you treat Schiff's reagent with aliphatic aldehyde, there is a restoration of pink immediately. The pink color will be restored immediately in case of aliphatic aldehydes. If you take aromatic aldehydes or aliphatic ketones, there is a restoration of pink color, but the process is very slow. They restore pink slowly. Aromatic ketones, in this case, there is no restoration of pink color. Tollen's test or silver mirror test. The reagent is ammoniacal silver nitrate. The active component is AgNH3 twice plus. This one is used for identification of aldehydes. Ketone. The ketone which has alpha hydroxy ketones only. Not all ketones. Alpha hydroxy ketones. Hemiacetal, hydroxylamine, formic acid. These functional groups can be identified by using Tollen's test or silver mirror test. In this test, there is a formation of silver mirror on the walls of the test tube. Fehling solution, Fehling test. The reagent has two solutions, Fehling A and Fehling B. Fehling A has blue color, Fehling B is colorless. The Fehling A is copper sulfate, Fehling B is Rochelle salt. The name of Rochelle salt is potassium sodium tartrate. When you treat with sodium hydroxide, finally there is a formation of, when you mix Fehling A, Fehling B, you will get Fehling solution. Here the active component is copper tartarate. This is the active component of Fehling solution. This is used for identification of aliphatic aldehydes, alpha hydroxy ketone, hemiacetols, formic acid. Ketones cannot be identified by using Fehling solution. Here there is a formation of a brick red precipitate due to formation of cuprous oxide. The precipitate is due to formation of cuprous oxide. If you take Benedict's test, okay, the reagent is sodium carbonate, sodium citrate, copper 2 sulfate. When you mix these compounds, you will get copper citrate. What is the difference between Fehling's and Benedict's? Here the metal ion is same, copper 2. Here also the metal ion is copper 2. But the ligand, in this case, Fehling's case, the ligand is tartarate. In the case of Benedict's, the ligand is citrate. This is also used for the identification of aliphatic aldehydes, alpha hydroxy ketone, hemiacetols, and formic acid. In this case also there is a formation of brick red precipitation. The next one is sodium bicarbonate test. The reagent is NaHCO3. This one is used to identify carboxylic acids or COOH. There is a formation of brisk effervescence due to evolving of CO2. Ester test. This is used for the identification of carboxylic acids. The reagent is ethanol or methanol in presence of concentrated H2SO4. Here there is a formation of ester. The smell of ester is a sweet smell or fruit-like smell. Solubility test. When you treat with dilute HCl, if the compound is soluble, the compound may be amine. When you treat with the dilute NaOH, if the compound is dissolved or soluble in dilute NaOH, the compound may be carboxylic acid or phenol. When you treat with sodium bicarbonate, the compound is soluble, then the compound will be carboxylic acid. Litmus test. If you dip blue litmus, when it is converted into red, the compound is acidic. The organic compound will be phenol or carboxylic acid. When you dip red litmus, if it is converted into blue litmus, it's a basic, the organic compound will be basic, so it should be amine. Carbylamine test. This one is used for the identification of primary amine, both aliphatic amines and aromatic amines. Primary aliphatic and primary aromatic amines can be identified by using carbylamine test. This one is very, very important. The reagent is chloroform, alcoholic KOH. There is a formation of offensive smell, obnoxious smell, due to formation of isocyanide. Iodide test. This is used for the identification of aromatic primary amines only, not aliphatic, only aromatic primary amines such as aniline. Aniline can be identified by using iodide test. Okay, the reagent is NaNO2 plus HCl. This one forms HNO2, nitrous acid. Okay, first you have to treat with nitrous acid, then you have to treat with beta naphthol. In this test, there is a formation of scarlet red color solution due to formation of dye. Nitrous acid test. This is used for the distinguishing of primary, secondary, and tertiary amines. The reagent is NaNO2 plus HCl. This one forms HNO2, nitrous acid. So when you treat with nitrous acid, the primary amines forms N2 gas. The primary aliphatic amines forms N2 gas. There is a bubbling of gas. In case of secondary amines, there is a formation of yellow oil. And tertiary amines, these are soluble in nitrous acid. Hinsberg test, the reagent is benzene sulfonyl chloride, and after that you have to treat with the sodium hydroxide. In case of primary amine, the compound is soluble. Secondary amines, these are insoluble. And tertiary amines, these are also insoluble when you add benzene sulfonyl chloride and sodium hydroxide. But if you add HCl to the resulting solution, there is a soluble upon addition of HCl. It indicates the amine is a tertiary amine.
In coming videos, I will explain in detail each and every test of identification of organic functional groups. Thank you for watching. Thank you.